Okay, so this question is from a physics physics GCSE workbook where the questions are targeted between 8 and 9, so they're all super hard questions. This question, no exception. It's quite a hard question, and it really gets your brain thinking in a sort of mathematical way. So the earlier parts of the question, what they were doing was they were asking you to identify the amount of energy lost, or calculate the specific heat capacity of something. So just to remind you, the specific heat capacity is worked out by the formula is energy is equal to the mass times the specific heat capacity times the change in temperature. So if you wanted to work out the specific heat capacity, you would rearrange that to be energy divided by the mass times the change in temperature. So if we knew the mass, which we do, it's 6 kilograms, and we're able to measure the temperature, which we can using a thermometer, and if we were able to know what energy went in, which we do because we can actually calculate it using a stopwatch, and the power so the energy would be equal to power times time, and power in this case is voltage times current. So the energy would be equal to voltage times current times time, and we'd be able to use a stopwatch, the voltmeter and the ammeter to calculate how much energy in theory went into this block, and then see what temperature rise did this cause for a 6 kilogram block of block of lead. Now that is making the presumption that no energy is lost, because clearly if we put all this energy in and like loads of it went out, then it's not going to the change in temperature is not going to be as great. So we have to insulate the block so as we can make a fairly good approximation that not much energy or negligible amount of energy is lost. So that is a big assumption. So in the earlier part of the question, it would have been voltage times current times time divided by the mass times the change in temperature. Now that top bit, voltage times current times time, we've worked that out, and that's done. We did that in a previous question. We know that the mass to be 6 kilograms, and this is the bit that would cause the problem. Okay. Now the earlier part of the question, we calculated the specific capacity to be 204.54. Now, in theory, we don't really actually need the numbers because they're not asking us to calculate anything. They're asking us to explain something. Okay, but it's quite nice to be able to use numbers to be able to visualize what's going on a little bit more. So, and the energy which we calculated from the heater ended up being 5,800. Just erase that. 5,800. No, that's wrong. 58,000 joules. That's the amount of energy that went in. So we're assuming that. Let's just read the question again. It's saying, explain how the value obtained for the specific heat capacity would change. So explain how. So what we're going to do is saying, is it going to go up or down? Is our value for the specific capacity going to be too high, or is it going to be too low, and why? Okay, so that's kind of what it's asking. And if the insulation at a high, and this is now testing your understanding of higher thermal conductivity, or what does that word mean? Well, thermal we know means heat, conductivity something to do with conducting, so it's a thermal conductor, heat conductor. If it's a higher heat conductor, well, that would mean it's a poor insulator. So in other words, what they're asking is, if I insulated it with something which was not as good at insulating, then how might that affect our value for the specific heat capacity? Would it give me well, obviously it would give me an inaccurate specific heat capacity, but would that value that I'm going to get, would it be too high? Would it be higher than the true value for specific heat capacity, or would it be lower than the true value of specific heat capacity? Now, what we've calculated in the previous question is the true value, so we're saying that's the true value. Okay, and we and we are using the same sort of temperature. Well, let's say we're using the same temperature change, and what we're trying to work out is which of these things is also going to be untrue, and it's this one here. So let's say we measure everything else to be the same, but what let's say we keep. So if we don't realize that the energy is being lost to the surroundings and not causing the block to heat up, then the measured energy, the calculated energy from everything else that we've done, would actually be higher than the actual energy that went into the block, or that was kept within the block in order to change the temperature. So we might calculate, rather than calculating 58, the amount of energy that went in order to produce, so we're trying to get what amount of energy went into the block to get to 5,800. Also, the energy used. Let me use my mouse to give myself a bit more space. Energy used to heat up the block is going to be equal to the energy put in minus the energy emitted to the surroundings, or energy lost to the surroundings, but I don't really like to use the word lost when we're talking about energy, because energy can't be created or destroyed. But that would be fine in that context anyway. Energy emitted to the surroundings Okay, so what we're assuming is that is zero. It's not, because we have a thermal, it's never zero in fact, but even if you have the best insulation, but obviously it'll be close to zero, we're going to say we have a higher thermal conductivity, so a worse insulation, so a non-negligible, or basically a worse insulated, which is not as good. So the energy used to heat up the block is actually going to be lower than this one here. So this is the energy put in, so that's the actual energy, and this is the energy put in is the measured energy. So the energy put in by the heater is what we think is the measured energy, when actually we don't realize that some energy has been lost, so that's going to be less. So when we calculate, let's say we get the same temperature change as before, so we are actually we're going to be using the same energy, but the difference is we're going to be assuming it's that. So that might be equal to, let's say it was 600, 60,000 joules plus 20,000 joules. Oh, that's wrong. Take away 20,000 joules. So this is the energy put in by the heater. I actually had to put 60,000 joules, but this is the energy was hypothetically lost by into the surroundings. So now I think that's the true value. So what would happen then to my measured value of C? Well, we can, if we say that we're measuring the same temperature change, but we think we had to put this much energy in, not realizing that that much energy was lost. Then when we calculate it, the specific capacity, well, we can kind of forget about that bottom bit and just say the specific capacity is actually directly proportional to our measured change. We could say our calculated specific capacity is directly proportional to the voltage times the current times the time. This is our measured specific capacity, the one that we're going to make the mistake on. And we can see here that it's the voltage times current times the time. And so because that's actually going to be too high, so that's going to be our 60,000 joules, then we would get a higher value of specific capacity. So the value would be C would be too high. Too high. In fact, I'll now just reveal what's behind the box. So if we zoom in, what does it say here? Okay, let's try that again. Higher thermal conductivity would mean energy would be transferred at a higher rate to the lead from the lead to the surroundings. Okay, I said it was that more heat was lost, but I think I'd get that mark. This means the temperature of the lead would increase at a lower rate, which would give a higher value of specific heat capacity. So higher value of specific capacity, as more energy is transferred for a given increase in temperature. So if we imagine that it's the same increase in temperature, then we're going to, when we try to cause that same temperature change, what we're actually doing is losing some energy to the surroundings. So this last bit, it talks about how specific capacity is inversely proportional to temperature change. So it's a bit of a weird way to phrase it really in the answers, but essentially I guess what it's saying is that if there weren't energy lost, then you would expect a larger temperature change. And so in our case, the temperature change has not been as much because, or you could imagine it's gone up, but then it's gone down again because we've lost energy to the surroundings. So we can say the measured temperature change that we're getting is actually too low. You could think about it that way. And so therefore the temperature change that we've measured is too low. It should be higher. And because it's actually higher than we're really measuring, then we could say the specific capacity is going to be inversely proportional to that. And so our specific capacity would be lower than what we're measuring. Okay, that's the best way I can think about explaining it at the moment, I think. So I hope that made sense. I hope I made some sense of that as I went through it. Yeah.